Alright, welcome back. This is part 2 of section 8.6. In part 1 we talked about double angle formulas, and now in part 2 to finish it up we're going to talk about half angle formulas. So this is what we can use if we want to cut an angle in half instead of doubling it. These formulas are a little bit more complicated, so we don't really see too much as far as identities go, but we will be using them to evaluate exact values of trig functions for some special looking angles. And also, of course, building a triangle. So those are the two examples we'll do. Pause, write them down if you need to. What I want to mention about these formulas, first of all, they use alpha, but that's not a big deal. Alpha is just representing any angle like theta would. We have sine of alpha over 2 equals, all of them have a plus or minus sign. So you'll notice that our final answers will not have both a plus and minus sign. It's up to us in the problem to decide whether the answer is going to be positive or negative, and that's determined by the quadrant of the half angle. So the angle that we're given, alpha over 2, we have to determine what quadrant that's in, and based on that, is this going to be positive or negative? So we'll see an example, of course, where we have to deal with that. So write these down, sine, cosine, and tangent. We're going to do our first problem now. So our first one is to find the exact value of cosine of 22.5 degrees. So 22.5 is an unusual angle, definitely, but what you'll notice is that it's actually half of a very common angle for us. So 22.5 is half of what? It looks like it is half of 45. So if I took a 45-degree angle and cut it in half, I would get 22.5. So that's what we're going to do. We're going to take a 45-degree angle, cut it in half, using these formulas up above. So of course I want to use the cosine formula. Let me rewrite this problem again. So cosine of 22.5 degrees is the same as cosine of 45 degrees over 2, right? 22.5 is 45 divided by 2. So that'll help us use this cosine formula, which is written right here, where alpha is going to be 45 degrees. So I'm just going to make a note of that. Alpha is 45. Let me write down the formula again so we have it. So this is plus or minus, and we're going to decide very soon what that is. The square root of 1 plus cosine alpha over 2. So I'm going to decide right now whether or not this answer is going to be positive or negative. We have to look at our angle, our half angle, this angle, 22.5 degrees, see which quadrant that's in. It's a very small angle, so this is going to be in quadrant 1, 22.5 degrees. And we know all things are positive in quadrant 1. So therefore, this is going to be a positive answer. Now that we've decided that, we don't have to write the plus or minus anymore. We know it's going to be a plus. So let's go ahead and make it positive, and then continue filling in this formula. So as I described, in this formula, we want to plug in for alpha 45 degrees, because that's the angle that's being cut in half in this problem. So I'm going to plug in 45 degrees for alpha, and then it just becomes a simplification problem, which is usually where all of the work in these problems is. So I'm going to figure out first what cosine of 45 degrees is. We know that that's square root 2 over 2. And then what I want to do is add these two things together on the inside. So our goal really now is just to simplify this. So we want to add together. We need a common denominator. This might take a little bit more room, so I'm going to start writing over here. So we have a square root. To get a common denominator, I'll turn 1 into 2 over 2. So that way we can add it to square root 2 over 2. When we do that, we can just add the numerators, or at least write them over one denominator. So I'll have 2 plus square root 2 over 2. And don't forget, this is all over 2. Finally, we can KFC on the inside. because we're dividing a fraction by a fraction. You might say, well, we're just dividing by 2, but remember, anything can be written as a fraction. So we're dividing by 2 over 1. So I'm going to KFC, keep flip change. I'm going to keep the top fraction the same. I'm going to flip the bottom fraction upside down and then change this to multiplication. So that didn't really help us too much in the fact that nothing is going to cross out, but at least we can make this one fraction. So this is the square root of 2 plus the square root of 2 all over 4, like that. Now we can simplify this more, and I'm going to show you how we are going to do that. So down here, what you can do when you square root a fraction is you can break it up. You can square root the top, and you can square root the bottom. How that's helpful is when we square root the bottom, we can actually do the square root of 4. That'll nicely be just a 2. So this is the simplest form of our answer. Square root of 2 plus the square root of 2 all over 2. Sometimes on multiple choice questions, they'll take this over 2 and write it as a fraction in front. So they'll just say 1/2 and then write it like this. Oops, there's my square root 2. So that's the same thing. I don't really have a preference either way. I'm just showing you multiple choice questions might have it written like the second way instead of this first way. But they're the same thing. All right, so that's the exact value of cosine of 22.5 degrees. If you don't know now, you know. That's what they say. Okay, so we're going to do one more problem together, and that is a build the triangle example. So very similar looking to the one that we did in part 1 of this section. We're given sine of alpha equals, this time it's negative 3 over 5, and we're told that alpha is between pi and 3 pi over 2, so that's telling us the quadrant that alpha's in. And now we want to find some half angles. You'll notice on this slide I crossed out part B, not because there's anything wrong with part B, it's just similar to part A, so I'd rather save some time and just do part A, skip part B, and show you part C, because tangent, as we know, has a little bit more complicated of a formula, so it's good for you to see that one. Okay, so let's go ahead and set this problem up. Let's build a triangle, because we know that that's what we're going to do. So I'm going to build this triangle over here. Draw a right triangle, call that angle alpha. We know that sine of alpha is negative 3 over 5. Sine is opposite over hypotenuse, so we can label our sides accordingly. We will want to find that missing side. You can use Pythagorean theorem to find that missing side, which we've done a lot, so I trust you to be able to do that on your own and find that that should be a 4. Now I'm not labeling the sides negatively, I never do that. I let the quadrant tell me what the sign should be. So that's why it's important for us to know this, which is telling us that alpha is in Q3, right? Alpha's between pi and 3 pi over 2, so it's in quadrant 3. Great. One thing that we're going to need to know, well, let me write the formula down so I'm not spoiling it. I'm very excited. I love these problems. So let's go ahead. This should be enough for us to start answering our questions. So part A asks us sine of alpha over 2. So I'm going to write down the formula. It is plus or minus the square root of 1 minus cosine alpha over 2. So what I'm going to decide right away is if this answer is going to be positive or negative. And that's determined by the quadrant that alpha over 2 is in. So that's important. We only know which quadrant alpha is in, but we don't know what quadrant alpha over 2 is in. So I'll show you how we can find that over here. So I'm going to write down our condition that we have for alpha, which is alpha is between pi and 3 pi over 2. So I want to know where alpha over 2 is, not just where alpha is. So if I want to find where alpha over 2 is, just divide everything by 2. When we do that, we see that alpha over 2 is between pi over 2 and this will be 3 pi over 4. Oops, 3 pi over 4. So that's telling me where alpha over 2 is. Alpha over 2 is stuck between pi over 2, which is 90 degrees, and 3 pi over 4, which is an angle right in the middle of quadrant 2. So therefore, pi over 2 must be in quadrant 2, stuck between 90 degrees and 3 pi over 4. And just to illustrate that, pi over 2 is here, 90 degrees, 3 pi over 4 is here, so alpha over 2 really is very restricted. It has to be somewhere in there, between pi over 2 and 3 pi over 4. So that's in quadrant 2. That's important because now we can answer this question. Sine of alpha over 2. Well, since alpha over 2 is in quadrant 2, and we're looking at sine, sine is positive in quadrant 2. Remember ASTC, all students take calculus. This tells us what's positive in which quadrant. Sine is positive in quadrant 2. So therefore, this answer should be positive. All right, so don't forget to check that. A lot of us will just look at the quadrant that alpha is in, but that's not what we're asked about. Alpha over 2 is what we're asked about. So that's going to be positive. And now we can fill in the rest of this. So we need to figure out what cosine of alpha is. So that's how we're going to use the triangle that we just built. We want to look at it. Cosine is adjacent over hypotenuse, which is 4 over 5. But don't forget to check the quadrant. This time we're looking at alpha, cosine of alpha. Alpha is in quadrant 3. So in quadrant 3, cosine is going to be negative. So I know it's a lot of sign checks. That's why this is happening at the very end of this chapter, because we've gotten a lot of practice checking for signs and quadrants in the last 2 chapters. So it's a lot of back and forth, but I know you can do it because we've had so much practice. Cosine of alpha is negative 4/5. And now it's up to us to simplify this, so that's what I'm going to do here. I'm going to do it a little bit faster because it looks kind of similar to what we did in the previous problem. So we have 1 minus negative 4/5, thus 1 plus 4/5. I'm going to, in one step, add 1 plus 4/5. 1 is 5/5, so 5/5 plus 4/5 is 9/5 over 2. We can make that 2 into a 2 over 1, and that'll let us KFC. So we can keep 9 over 5, flip 2 over 1 to be a 1 over 2, and then change this to multiplication. It doesn't really cross anything out, but at least it lets us write this as one fraction, which will be 9 over 10. When you have the square root of a fraction, you can take the square root of the top and the square root of the bottom. That'll help us simplify to be a 3 over square root 10, which is an okay answer, but it's not rationalized. So remember how to rationalize. You can just multiply by the denominator on the top and on the bottom. And that should give us our final answer here of 3 square root 10 over 10. Whew, so there we go. That was sine of alpha over 2. Lots of things to check, lots of signs that can go wrong. So make sure that you're paying attention, rewatching this discussion. If you need to, pause and rewind it. We're going to do one more problem, part C, just to get a little bit better hang of this. Part B is very similar. If you want to try that on your own, you can. I actually have the answer here on the slide, I believe. Yes, so for part B, if you try it on your own, you should get negative square root 10 over 10. So feel free to try that on your own. I'm going to do part C together with us. So here's part C. Tangent of alpha over 2. I'm going to write down the formula. So the formula is plus or minus 1 minus cosine alpha over 1 plus cosine alpha. Now we have to determine if our answer is going to be positive or negative based on the quadrant of alpha over 2. So as a reminder, alpha over 2 is in quadrant 2, and we discussed that right here. Alpha over 2 is in quadrant 2. We're dealing with tangent in part C. Tangent is negative in quadrant 2. So the answer to this part C should be negative. That's also why in part B we had a negative answer, even though I didn't show you. Here's the answer to part B. Cosine is negative in quadrant 2, so that's why that answer was a negative answer. Okay, so we know it's negative now. Don't forget that. So I'm going to put a minus sign in front of this square root. And now it's up to us to fill in these cosines. So cosine alpha we have in 2 places here. We already know what that is because we did it in part A. Cosine alpha is negative 4/5. 4/5 because we use our triangle. Negative because alpha is in quadrant 3 and cosine is negative in quadrant 3. So we put negative 4/5 in both of these places. And just like before, this is going to be some simplification work. So I'm going to move my work all the way over here to the left to make sure that I have as much room as possible. And I'm going to simplify this. So getting rid of these parentheses, I have 1 plus 4/5 on the top. On the bottom, we have 1 minus 4/5. You want to get a common denominator and add those fractions together. So on the top, 1 plus 4/5 is 9/5. On the bottom, 1 minus 4/5 is 1/5. Now we can KFC. So keep the top fraction the same, flip the bottom fraction upside down, and then change this to multiplication. Ooh, and this time, this is going to be great. So the 5's cancel. We end up getting a negative square root of 9 over 1, which is 9. And the square root of 9 is, of course, 3. So our final answer here is negative 3. Who would have thought that would have ended up such a pretty answer? But hey, it happens sometimes. So tangent of alpha over 2 is going to be a negative 3. All right, lots to work on, lots to check, lots to practice. Please make sure you're practicing, asking any questions if you have them. Otherwise, good luck, and I will see you in the next chapter.